Assalamu alaikum. Welcome to my channel Learn with Fun by Zarrar sir. Today we're gonna discuss about a very interesting topic, which is superposition theorem. So I'll make sure you understand superposition theorem with an example. So let's start with this example. I'll take the resistance over here as 10 ohms. 10 ohms. The resistance over here as 5 ohm, and I need to calculate the current across this 5 ohm using superposition theorem. I'll take this resistance as 10 ohm. Okay, let's take some lower value resistance also to understand it more precisely. I'll take it as zero point 0.2 ohm. Okay, and I'll take this resistance as 0.1 ohm. Okay, I'll take this voltage as 2 volt. Okay, I'll take this voltage as 2 volt. I'll take this voltage as 4 volt. Now let's try to analyze this using superposition theorem. If this problem needs to be solved using KVL, then it is very simple. But now let's make sure I'll try to make sure that you understand this using superposition theorem. It is very easy and very interesting topic. In superposition theorem, there is one concept that you need to remember, okay, which is we have to consider one source at a time. Okay, consider one source at a time, only one source, and make sure whenever you consider one source, make other source depend on their internal resistance. Like we are considering voltage source, make other source voltage source has to be shorted, and while you are considering voltage source, and if there is any current source present in the circuit, make it as open. Okay, so let's try to analyze this. So the first step is I am considering 2 volt. Don't worry, there is one more example you'll understand with the current source also. So I'm considering 2 volt source acting alone. If I consider 2 volt source acting alone, okay, so now I'm considering 2 voltage source 2 volt source acting alone. Now see, you have to short this voltage source. So I'll short this voltage source, which is 4 volt. I'll short this voltage source, and I'll apply KVL in this two loop. This is first loop and this is second loop. I'll name it as I1 and I'll name it as I2. Now if you apply KVL, you know the shortcut of KVL, right, which you have already learned. You have to add all the resistance in the first loop. Okay, you have already learned the shortcut. What to do? You have to add all the resistance. So I'm applying KVL in loop 1, applying KVL in loop 1. If I apply KVL in loop 1, what will happen? 10 plus 5 plus 0.1 is 15.1. So 15.1 I1, right? 15.1 I1 minus 5 I2. Okay, this resistance is in second loop also. So minus 5 I2 is equal to 2 volt. This is my equation number 1. Okay, this is my equation number 1. Now let's take equation number 2. If I apply KVL in loop 2, what will happen? I am applying KVL in loop 2, applying KVL in loop 2, and if I apply KVL in loop 2, what will happen? Just add all the resistance of the loop 2. 10 plus 5 plus 0.2 becomes 15.2. So I'll write plus 15.2 I2, and this 5 ohm resistance is in loop 1, so minus 5 I1. You know the shortcut, I've already taught you in KVL video, is equal to 0. So now you have two equation and two unknown, and if you solve two equation and two unknown using simultaneous equation, you will get the value of I1 and I2. I'll directly write the value of I1 and I2. You will get I1 over here as 0.0141 ampere, and I2 over here as 0.0028 ampere. 0.028 ampere. Okay, so this is I2. Now if you look properly, the current flowing through 5 ohm resistor is this current, which is I1 minus I2. So I'll name it as I dash equal to I1 minus I2, and if you subtract I1 minus I2, you will get voltage as 0.113 ampere. This is your I dash, the first current, right? When you considered 2 volt source acting alone, this 2 volt source was acting alone. Now we'll consider the source which we have not used till now. So this is the next step. I name it as step 2. Okay, let's name this as step 1. So step 2 is considering 4 volt source acting alone. Okay, now consider 4 volt source acting alone. Now I'll erase this 2 volt. Okay, and I'll make short over here, and now I'll erase this part and I'll draw 4 volt source. Okay, so let's draw 4 volt source. So this was my 4 volt source, and now I'll apply again KVL. So if I apply KVL in loop 1, if you apply KVL in loop 1, what will be the equation? Again 10, see this is 10 plus 5 plus 0.1 becomes 15.1 I1 minus 5 I2, since 5 ohm is in another loop, equal to 0. This is the equation number 3. Okay, now if I'll apply KVL in loop 2, apply KVL in loop 2. If I apply KVL in loop 2, now see what happened. 10 plus 5 is 15. 15 plus 0.2 is 15.2. This resistance is in this loop, so I'll write minus 5 I1 plus 15.2 I2 equal to, now we have a voltage over here which is positive first, so I'll write minus 4, and this is now equation number 4. Now if you solve this equation number 3 and 4 simultaneously, you will get the value of I1 and I2. So I'll get I1 equal to, I'll get I1 value as minus 0.056 ampere. Okay, and you will get I2 as, I2 you will get as minus 0.169 ampere. Okay, what is your current flowing through 5 ohm resistor? It is I1 minus I2 again. I'll name it as I double dash, and your I double dash will be I1 minus I2, and if you subtract this, you will get again 0.113 ampere. Okay, see, it looks, both the value looks same, but it is not always same. In this problem I got this value as same. So this was I dash in first loop, I mean to say when I consider 2 volt source. This is I double dash when I consider 4 volt source acting alone. Now according to superposition theorem, I'm very sorry I have not left the space, so I'm using this space over here. So when you use superposition theorem, so using superposition theorem, if you use superposition theorem, using superposition theorem, you will write I dash plus I double dash, and which is, if you add 0.013 plus 0.113, like both 0.113, you will get 0.226 ampere. So this is your final answer using superposition theorem. This was first, this is the way to calculate superposition theorem if 2 voltage sources are given. Now let's consider another problem with 1 voltage source and 1 current source. Okay, hope you understand this within 10 minutes how to apply superposition theorem if you have 2 voltage source. If you don't want to apply superposition theorem, when we apply superposition, when we are asked to do superposition, you can directly solve this using KVL, which you have already learned. Now let's take another problem with 1 voltage source and 1 current source. Okay, so I'll move to the another problem with 1 voltage source and 1 current source. So this is the problem with 1 voltage source and 1 current source. Now I'll make 1 voltage source and 1 current source over here, and let's see we can analyze this problem or not. So I'll make this problem of one voltage source and one current source so that we can understand this problem and we can apply the logic properly. So I'll be using current source over here, and I'll name this current source as, I'll take the current source value as 1 ampere. Okay, let's take this resistance as we'll take a very small resistance, 2 ohm. Okay, let's assume there is a voltage source over here which is 1 volt. I purposely taken the 1 volt voltage source in between so that you can understand a complex problem also and you are able to solve the complex problem also. Let's take this resistance as 3 ohm. Let's take one more resistance over here. I'll take it as 2 ohm. Okay, let's take one more resistance over here, 2 ohm, and we'll try to find this value of resistance which is 1 ohm, which is outside the loop. Okay, so this is the problem. Now you can see there is one voltage source and one current source. And now how to solve such problem with one voltage source and one current source? This is a difficult, or I would say tedious task. So now we will understand superposition theorem with one voltage source and one current source. Now to solve this, we'll start with first step. We will consider only one source at a time. So I am considering first current source, 1 ampere source acting alone. Okay, acting alone. Now it's all your choice. You can consider 1 volt also. I am considering 1 ampere current first. So you are aware about when you consider voltage source, you have to open current source, and when you are considering current source, you have to short voltage source. So I'll short this voltage source. I'll remove this voltage source over here, and I'll short this terminal. Okay, this is 1 volt source has been removed. Now you apply KVL, which you have already studied. Okay, so I'll take KVL, I'll apply loop current over here, I1. Okay, let's take this to be as I2, I3 and I4, I2, I3, and let's take this as I4. From, as you can see, the problem looks very tedious because there are 4 current source. And how we can solve 4 current source, 4 current equation in a calculator? But if you look properly, you can directly write, this is the current I1 which is flowing in this loop, and there is a directly current source given. So you must be aware about a concept that we can write I1 is equal to 1 ampere directly, since there is no other current in that loop. So I1 is directly, you got 1 ampere, which is a very simple part of the problem. Now let's try to apply KVL in loop 2. So if I apply KVL in loop 2, if you apply KVL in loop 2, you can see if you apply KVL in loop 2, what you will end up with, you can directly write with the shortcut 3 plus 2 is 5, 5I2 minus this 2 ohm is in fourth loop also, minus 2I4 equal to 0. So this is very simple equation, right? Minus 2I4 equal to 0. So which is very simple. But if the student make mistake because they forget to consider this resistance 3 ohm. See, I2 current has 2 resistance, 3 plus 2, 5I2. 2 ohm is in fourth loop also, so I have written minus 2I4. But 3 ohm is in first loop, so we need to consider that too. So we cannot write 0. We have to consider resistance, which is minus 3I1 equal to 0, and you know the value of I1 is 1 ampere, so you can directly write 5I2 minus 2I4 minus 3 into 1 is minus 3, which will go over there and write 3. So this is the equation number 1 I'll write. Okay, so hope you are understanding. I've used this two resistance as 5I2 minus 3I1 minus 2I4 equal to 0, and you have the value of I1, you have substituted the value of I1, you get this equation. Now I'll apply KVL, applying KVL in loop, applying KVL in loop 3. Okay, if you apply KVL in loop 3, what do you end up with? 2 plus 2 is 4I3, 4I3 minus this 2 ohm is in fourth loop also, minus 2I4 equal to 0. So this was very simple equation. Okay, and now I'll apply KVL in fourth loop also, applying KVL in loop 4. And if you apply, I'll write this equation number 2. If you apply KVL in loop 4, 2 plus 2 plus 1 is 5 ohm. So 5i4 minus this 2 ohm resistor is in third loop also. So minus 2i3. This 2 ohm resistor is in second loop also, minus 2i2 equal to 0. So this is my equation number 3. As you can see, 3 equation has 3 unknown, i2, i3 and i4. And if you solve this in calculator, you will get the value of i2, i3 and i4 as, I'll get the value of i2 as, if you solve it into calculator, you'll get 0.75 ampere of i2, which I have already solved. i3 equal to, you will get 0.1875, okay, and i4 you will get it as 0.375 ampere. And if you look carefully, we need to calculate determine current through 1 ohm resistance, and the current through 1 ohm resistor is this current, which is nothing but your i4. So I can directly write my I dash is equal to i4 is equal to 0.375 ampere. So this I have get the current only when 1 ampere source is acting alone, and we have removed the voltage source. Now in the next part we will add this voltage source and we will try to analyze the equation. So let's add the voltage source and remove the current source. And you are aware about, if I add the voltage source, I need to open the current source and the circuit will look like this. So you can see the current source has been removed. Okay, what is the value of resistance that we have considered over here? The value of resistance over here was 3 ohm. Okay, the value of resistance over here was 2 ohm. Here also I have considered 2 ohm. Here also it was 2 ohm, and this is what our important resistor. The value of this resistor was 1 ohm. Okay, and the final is voltage source, and you are aware about the voltage sources. The voltage source what we have considered is 4 volt, sorry 1 volt. So this is the important voltage source that we need to consider, which is 1 volt. Okay, I'm very sorry, let's write it properly. This is 1 volt. Okay, now let's apply. So now move to step 2. I'll write step 2, I'll consider 1 volt source acting alone. If I'll consider 1 volt source acting alone, I'll apply KVL in this 2 loop. Okay, if I'll apply this KVL in 3 loop, I'll now name it as I1, I2 and I3. Okay, and you are now being very perfect in applying KVL. Let's apply KVL. I'll apply KVL in loop 1. If you apply KVL in loop 1, what will happen? Try to understand the equation. If you apply KVL in loop 1, you will get 3 plus 2 as 5i1 minus this 2 ohm is in third loop also, so 2i3 is equal to, you are moving from, as you can see, you are moving from positive to negative. You need to subtract, so you will write minus 1. So this is your equation number first. Now similarly I'll apply KVL in loop 2. Now if I apply KVL in loop 2, 2 plus 2 is 4. Okay, 2 plus 2 is 4 minus this 2 ohm is in I3 also. So 4i2 minus 2i3 is equal to, and now you are moving from negative to positive, that means you will have positive plus 1. So this is my equation number 2. Okay, it was very simple. Now if I apply KVL in loop 3, and you can see if I apply KVL in loop 3, this is my loop 3. Add all the resistance of loop 3. 2 plus 2 is 4, 4 plus 1 is 5. So it is 5i3 minus 2 ohm is in first loop, so minus 2i1. 2 ohm is in second loop, and the current are opposite in direction, so minus 2i2 is equal to, there is no voltage source in the third loop, is equal to 0. So this is my third equation. Hope you have understand all the three equations. Now once you have got all the three equations, you'll use the calculator to solve all this simultaneously, and you'll get the value of I1, I2 and I3. And I've already solved it for you so that your time should not be wasted. I have calculated it is minus 0.1875 ampere, okay, and over here I2 is 0.265 ampere, which is not important to us since we are concentrating on third loop, because I1 ohm is in third loop. So I3 is directly, you can write I3 as 0.031 ampere, okay, and I double dash will be I3, which is equal to 0.031 ampere. So now my total using superposition theorem, if I using superposition theorem, I will be I dash plus I double dash, which is equal to 0.375, which we have already got, plus 0.031 ampere, and this is finally equal to 0.406 ampere. Hope you have understand superposition theorem. This was the superposition theorem. Please, this is the final answer. Please like the video, subscribe my channel and comment if you understand this, so that I can upload Thevenin and Norton in the next video. Thank you guys. Have a good day.